This is problem number 8 from the practice problems for test number 2. The function p of x equals 0 if x is less than 0, and 0.8 e to the negative 0.8x if x is bigger than or equal to 0 gives the probability that a person from a particular city lives x miles from the center of the city. A, confirm that p of x satisfies the conditions for a probability density function in that the area between the function and the x-axis is 1, and the function is always greater than or equal to 0. So let's start with the greater than or equal to 0 part. If you are in the first row, then you are 0, so you are always more than or equal to 0. If you're in the second row, then you have to do with the e function. But we know that e to anything, and in particular e to the negative 0.8x, is always positive. Throwing a 0.8 in the front doesn't change it. So we've satisfied the easier condition. The tougher thing is to show that the total area under that curve is equal to 1. So let's start by writing an integral for our area. So the integral from, we'll put the limits in a moment, but the integral of the probability density function. So it's supposed to be the total area far left to far right. So far left really means far left, minus infinity, and then at the far right to infinity. This is a piecewise function, so we're going to split this integral up into 2 integrals because the piecewise function has 2 different rules. So where should we split the integral up? Well, let's go ahead and put the easy things here, minus infinity, and here, plus infinity. So where do we split this integral up? Well, the the function changes rules at x equals 0. So that is why we split this thing at x equals 0. And if you are between minus infinity and 0, that is to say you are less than 0, then your rule is just 0. So I'm going to put that rule right in here. So this is a 0 dx. Silly to write it, but we'll just write it. And then if you are between 0 and infinity, that is you are more than or equal to 0, then you are this rule. So we're going to put this thing into our second integral right over here. So 0.8 0.8 e to the negative 0.8x dx. Okay, the goal is for this entire integral to equal 1. So the first part is easy. The integral of 0 is just 0. So we have 0 plus. I'm going to continue to write the infinity, but at some point we'll need to change that to a letter and then take a limit. But let's just see if we can handle this integral here. This feels like a u substitution. We're going to let u equal the power. You might pause the video here if you want to take a few moments to do the u substitution and then come back when you've got it. So if you're back, hopefully you've got this. I'll copy the 0.8. That becomes e to the u. And instead of dx, we end up with a du over negative 0.8. And so this becomes integral, I'll pull the, well, we can actually cancel the 0.8, so we'll do that first. 0.8 cancels with this 0.8, so ultimately we just end up with a negative in the front of the integral, 0 to infinity, e to the u du. And actually, given that I've changed to a u, I actually should have changed the limits of integration. It's no longer 0 and infinity. So let's figure out what it should be. So if x is 0, then u is also 0. Fine. If x is infinity, then how much is u, according to that equation in black, is actually negative infinity. And I think that's going to be important. So I'm obliged to change it to a 0 to minus infinity. 0 to minus infinity. Okay, so this is the integral that we need to do, and because we've done the u substitution, the integral is easy. This is negative e to the u, evaluated between 0 and minus infinity. I'm not going to write out the details, but I will say replace that minus infinity with b, or some letter, and then take a limit. So I'm going to do something here that I'm going to ask you not to do, because there's a class coming into this room pretty soon. I'm just going to go ahead and do this without the proper notation with those limits. So this is equal to negative e to the, we'll plug in the top number, negative infinity, minus negative e to the plug in the bottom number, 0. So this is the part which I don't really like. Having e to the minus infinity doesn't look very good to me. I should have done it the right way. But e to the negative infinity is very, very close to 0. And then minus minus makes plus, and then e to the 0 is 1. So ultimately we get 1, which is what we were after. So the total area underneath this p of x function from the top is equal to 1. So it satisfies both conditions for a probability density function. Part B, what is the probability that a randomly chosen person from this city lives between 2 and 4 miles from the city center? So in this case, what we're interested in finding is the area between 2 and 4 underneath this curve. So we need to put the p of x function here and go between 2 and 4. It's basically part of the definition of a probability density function is that if you want to find the probability that something happens in an interval, you just integrate the function over that interval. So integral from 2 to 4 in this case, because these x's, the x's between 2 and 4, are all positive, you're only in the bottom row here. So we're just going to replace right away. We don't have to deal with the 0 on the top. This is 0.8 e to the minus 0.8x dx. I'd encourage you to do some work. I'll put dot, dot, dot. This is the same u substitution as we did above, but ultimately we're going to get down to a decimal, which I will just write, 161, which means that there's about a 16.1% chance that a randomly selected person will live between 2 and 4 miles from city center. And then part C, find the formula for the associated cumulative distribution function. So here, what we're interested in is the CDF. And we know the CDF is the integral of the PDF. But now going from minus infinity up until some kind of generic variable up there. I'll call it t. Okay, so the integral from minus infinity to t is actually the same as the integral from 0 to t, because until you get to the positive numbers, the PDF in this case, that function at the top, is just 0. So it doesn't contribute anything until you get to the positive values of x. So let's copy the formula right here. This is 0.8 e to the minus 0.8x dx. And again, it's the u substitution. I'm just going to kind of jump to the answer here. The answer is e to the minus 0.8x and a negative sign in the front. And this is between 0 and t. So that's basically the same thing that we had up here when we got around to this e to the u with a negative sign in the front. Here we had to change the limits. I'm not going to change the limits because I didn't actually write out the u substitution. So I think we're good here. And then we'll plug in. The x becomes t, and then it becomes 0. Negative e to the minus 0.8t minus negative e to the minus 0.8 times 0. Okay, we'll copy this part. Minus minus makes plus. Anything to the 0 is 1. So ultimately we get 1 minus e to the negative 0.8t. And pretty much that's the answer. I guess it's probably a little bit better to have x instead of t. So I'm just going to say replace t with x. The original problem, the original PDF, that probability density function, the probability density function had x, so it feels like the cumulative distribution function should also have x. So then I will just say this equals 1 minus e to the minus 0.8x. And for kicks, you might take a look at the graph of that function and maybe compare it to the graph of the original function, this p of x up here. You can draw them both on the calculator and just see if you kind of buy into the idea that as you accumulate area under this function, that you do get this guy right here. The two functions should go hand in hand. So you might try to make some connection for yourself by looking at the two of them simultaneously.